All right, this video is going to cover conditional probability and two-way tables. To first start off, let's talk about what a two-way table is. These are tables that contain specific categories in the top row. So we're looking at the top row and left column. So if we look down here, even though it's empty, we can still see top row means here are your categories. And then left column, we've got other categories down this way. They represent data over the frequency of the categories and totals. So we're saying how often is it a fox? How often is it unshaded? How often is it a fox and unshaded? And it's also going to have these categories of our total unshaded, total shaded, total foxes, etc. So let's just go straight into it, and let's go ahead and take a look at our picture over here and fill in our table. So what we're going to do is we're going to look for the intersection, which is going to come up in a little bit, the intersection of shaded and fox. We're going to see how many shaded foxes are in this diagram, and we count 2. We're going to keep moving. Let's go ahead and look at shaded dolphins. Here I've got 1, 2. Now we'll look at shaded squirrels. I only see 1. Shaded cat, right here. Oh, only 1. Shaded penguins, only 1. So now we want the total of shaded animals. Okay, so this is the total of all shaded. We're going to end up with 4, 5, 6, 7. So now let's take a look at our unshaded. So we have unshaded fox. Looks like we only have 1 there. Unshaded dolphins, we've got 2. I'm going to speed up a little bit. Unshaded squirrel, over here, see we've got it way over here. We've only got 1. Unshaded cats, we got 1, 2, 3, 4. And your unshaded penguins, we got 1 up here and then 2, 3, 4, 5. So now we'll look at the total unshaded animals, and we add all these numbers up together, we're going to get 13. So we've got the total shaded, total unshaded. Now let's take a look at the bottom row over here. Now we want the total foxes, the total dolphins. So including shaded and shaded, how many total foxes did we have in this diagram? So we add these to get 3, these to get 4. These aren't hard numbers to add up, okay? And then this bottom corner right here, bottom right corner, should be the same whether we add shaded and unshaded right here, or whether we add all the animals together. What is the total number in this diagram? We're going to wind up with 20. So this right here, we want to see as your grand total. Okay, total number of animals. So if we're looking at a total number of animals, we need to use that 20. So we're going to take the look at, we're going to use this table, and we're going to find the probabilities of each of these happening, assuming that we're going random with this. We're looking at the probability of a fox. So what we need is, okay, well, how many foxes do we have? Over here, we've got a total of 3 foxes out of the total amount, which is going to be that grand total of 20. So your probability is simply just 3 out of 20, and this is simplified. Now, when we look at B, we're looking at a dolphin or a squirrel. This word or is going to be extremely important. This word or means we need to take the dolphins and we need to take the squirrels, the numbers, and we need to add them together. Okay, so we're going to take dolphins. I'm just going to kind of abbreviate. Total number of dolphins is 4. Total number of squirrels is going to be 2. And your grand total is going to be 20. So it's going to be out of 20. And we need to take that 4 plus that 2. So we have a total of 6 out of 20, which this will simplify to 3 out of 10. Now we're going to look at the word and. This word and right here is going to mean the intersection. So here we've got intersection, and this is where I said earlier we'd be looking at the intersection. Where do these two meet inside that table? So we want to look at cat and unshaded. So we're looking at how many unshaded cats do we have? So we look at our table and we have unshaded and cat. Where do they intersect? Here at 4. So we write this is 4. Out of our total, which is that 20. So we get 4 out of 20, giving us reduced down to 1/5. Notice how all of these are none of them, sorry, let me put it this way, none of them are improper fractions. Okay, your probability is going to be less than 1, right, in those fraction form. Now this next one, we're going to cover a little bit more conditional probability, but this line right here is going to mean given. So what we're saying here is a probability of a cat given that the animal is shaded. So I'm going to write that down, and then it's going to pop up here. We're going to write probability of cat given that the animal is shaded. All right, so there's what it looks like. That's what we're saying. So we're not going to be doing the grand total anymore with this one. When you see this line, meaning given, okay, we're not doing grand total. What we want to do is, my suggestion is, I like to start with the second word, shaded. And let's look at how many shaded animals that we have. And we look up here, we're looking at shaded animals. We're looking at total of 7. Okay, so we're not doing grand total, we're doing total of the second word, the word on the right of that line. So the total shaded is going to be 7. Now when we talk about cat, we need cats that are shaded, both of them. So here we're putting the words together as shaded cat. We look up here where they intersect at your shaded and your cat, and we only have 1. So now, beforehand, we have the smaller number we listed first. It didn't matter what you list first whenever you say fox equals, total equals. But here, we need to remember that the smaller number has to go on in the numerator. So here, your shaded cat goes in the numerator, and the total shaded goes in the denominator. All right? So this is your conditional probability. When learning a dependent probability, we see this notation, probability of A given that B has already happened. So here we have already chosen all of the shaded cats. What's the probability of that cat? We've already chosen all the shaded animals. What's the probability out of those total shaded animals? What's the probability of it being a shaded cat? Okay, so that total is changing. So here we're looking at shaded and penguin. So shaded as long as it is a penguin. So what we want to do is we want to take the second one, probability of shaded given that it's already a penguin. So we're going to find the second one. Let's look at the probability of a penguin. I'm just going to put P-E-N. Up here, we look at penguin. Up here, how many total penguins do we have? 6. Now, we want the probability of the animal being shaded as long as it's only a penguin. So we can only look at the penguins. So we want shaded penguin. So here we're going to put shaded pen. So now we go look at where we have shaded and penguin, and we only have 1. So that's going to go 1. So smaller number in the numerator, larger number in the denominator. We have a probability of 1/6. The next one, let's start with that second word, unshaded. Let's look at how many total unshaded animals do we have. That's the goal here. The second one, we're looking at the total. Total unshaded, we have 13. Now, out of those 13, how many of those unshaded are dolphins? Okay, so we want unshaded, D-O-L for dolphins. If you need to spell it out, please do. Okay, so unshaded and dolphin, we have 2. So we have 2 out of 13. And that is how this pattern works. So let's look at a new one. We've got this table already filled out for us. And let's go ahead and check out some more examples. And as we get to the third page, I'm going to speed it up a little bit. All right? So here we're going to use this probability. The first one they want is clear sky or partly cloudy. Remembering that that or is going to tell us to add. So we're going to take the clear sky. I probably should spell that out, being the fact we have 2. Oh, we got partly cloudy. Okay. Clear sky, and we've got partly cloudy. Clear sky up here, total clear skies, 183. Partly cloudy, total partly cloudy is 127. Grand total, everything all together, 365. So we're looking at days during the year, okay? So we have 365 total. So we want to take the 183 plus the 127, your clear sky and your partly cloudy, all over 365. When we add those together, we're going to get 210 over 365. This can be simplified. We'll make sure everything is simplified down to the most simple fraction here of 42 over 73. And there's going to be our final answer. Now, the next one says probability of stormy, and it's May through August. So that word and is telling us we want the intersection. So we're not adding here. All we're doing is we're taking the intersection where stormy and May through August intersect, where they're going to meet. So here we want stormy and May through August. So we go up here, where is it stormy? And where is it May through August? Where do they intersect? 25. Out of our total, 365. So we have 25 over 365. This will simplify down to this will simplify down to 5 over 73. Sorry, 5 over 73. We're dividing by that 5. Now, we'll do my best to go up and down, showing this and showing the table. Partly cloudy, there's that line, given it's September through December. So the given, when we have that line between them, we're no longer using that grand total of 365. Okay, that corner is no longer being used. So here, we want to look at, okay, how many days are in September through December totally? Our total. So September through December, we'll look up that one. So here we go. September through December, we have a total of 122 days. Now, how many days in September through December are partly cloudy? So we have to look at where those intersect. So partly cloudy and September through December. So there's that word and that I'm writing here, remembering that and is the intersection. So here we're writing it, we want to find the intersection of partly cloudy and December. So we have partly cloudy and September through December, we have a total of 42. So, smaller number in the numerator, larger number in the denominator, and then we want to make sure that we have this simplified. This will go down to 21 over 61. Next, clear sky given it's January through April. So let's go see how many days are January through April. January through April, we have a total of 120 days. Now, out of that 120, how many had clear sky? So clear and, there's that intersection, January through April. Clear sky, January through April, they intersect, and it's 71. So we have 71 over 120, and this will be simplified already. There are a few that will already be simplified here. Next, stormy sky, given that it is May through August. So first we figure out how many days do we have that are May through August. So up here, how many days? We got May through August. We have a total of we have a total of 123 total days May through August. How many of those were a stormy sky? So we have stormy sky, and it's May through August. Let's find that intersection. Stormy sky, May through August. Where do they intersect? At 25. So we have 25 over 123. This is going to end up being simplified. Always double check that though. Last one for this example here. We want how many days are partly cloudy, how many days are in May through August that are partly cloudy. So first let's figure out how many partly cloudy days we have total. So go up here for partly cloudy, total number of days, 127. Now, how many days are partly cloudy? And also in either May through August. So again, that intersection of these two. So we have partly cloudy, and we wanted May through August. So we're partly cloudy and May through August intersect. We have 48. So So 48 out of 127, and this will be simplified. Last example, we've got ice cream, and whether we're talking about a young child, a teenager, or an adult. So these are going to be the flavor preferences of these ice creams. So the first one here, I'm going to go ahead and speed it up this time, or vanilla or strawberry, tell us to add. So I'm going to go ahead and put them right here together, vanilla, or strawberry. I guess I can make that a little bit neater there. You know what, let's just go ahead and go like we were. We got vanilla. Let's just go ahead and say how many vanillas there were. Total vanillas, 92. Strawberry. Total strawberries was 70. Now, we want to add these together, okay, out of our grand total. Remember, unless we have that given line, we're doing this out of the grand total, which here the grand total will be 269. So out of the total, 269. So we take our 92 plus our 70 over grand total. We add the 92 plus the plus the 70. We're going to get 162. Sorry, this is 162 over grand total 269. And this will, if you put it in the calculator and look at it, it will be completely simplified. Now we're going to look at a teenager and chocolate. So again, that word "and" is going to mean intersection. We've been looking a lot at that lately with that given, with the given problems. So we want teen and chocolate. So where did the teenager and the chocolate intersect? We've got 12. Out of your grand total of 269, so 12 over 269. Now 269 is a weird number. It's going to have a lot of things already simplified here. Well, at least these two. All right. Now I got to move this up and down. Now we've got our givens, meaning we are done with the grand total. We are only looking at the totals right here and the totals right here, not that grand total. We're done with it because we have all four. Well, I'm sorry, we're not done. Well, we'll talk about that. E and F are going to be a little bit different, but here we're done with that 269. We want strawberry given we have a young child. So when you look at our total of young child, so young child, the total is 77, so that's the total we're using, just young child. And we want to know strawberry and young child. So this other one is going to be an intersection. We want strawberry only if it's the young child. We don't care about strawberry and teenager or any of that. We only want strawberry given it's out of the young child population here, 15. So we wind up with 15 over 77 simplified. All right, adult and chocolate. So let's look at how many, adult as long as they like chocolate. So we need to figure out how many chocolate we have first. Total chocolates. So total chocolates, we have 107. Now we want to see how many adults like chocolate. So they're adult and they like chocolate. So let's look at that intersection. Adult and chocolate, where do they intersect? 55. So we wind up with 55 over 107, and this will be simplified also. Now this next one is going to kind of combine what we've been doing. So here we're going to start off with vanilla, all right? So we want to start off with this vanilla. This is our given. So let's look at how many total vanilla do we have. All right, starting off the exact same. How many total vanilla? We have 92. Now we want to look at teenager or adults. So we need to take these, and we need to take teenager and the adult, and we need to add these together. We want a teenager or adult, so we need to combine those, but only the ones that like vanilla. Okay, so that's the thing, only the ones that like the vanilla. So we have teen or adult and also vanilla. So we're looking at teen or adult added together that like the vanilla. So the intersection of teen and adult. So here we have, teen and vanilla, teenager and vanilla. So we're looking at that intersection. Sorry, I've got to get it on the screen. 16. plus your adult and vanilla. So teen and vanilla was 16. Adult and vanilla is going to be the 54. So we're going to take those two. We're only looking in that vanilla section. We want the teenager, 16, or the adult. So we need to combine those together. 16 plus, make sure we're on the screen, plus your 54. This will equal a total of 70. So now we're going to have 70 over the 92. And this will simplify down, divide each one by 2. We get 35 over 46. So this is the toughest one because you have to do a lot here. Okay? The more practice, the better you'll get. All right, so now we're looking at the probability of somebody liking chocolate or strawberry, but only if they're adult. So we want to look at only the adult population here. So we're going to look at how many total adult population. What do we have? Adults total, 119. So we're only looking at the adults, 119. Now in that adult section, only in the adult section, right here, the 55, the 54, the 10, we're looking at the adults that like chocolate or strawberry. Again, we have that add. So here we need to look at adult that likes chocolate or strawberry. I did realize over here, if anybody noticed, I put an and. Oh, you know that. That's right. Sorry. I'm second guessing myself. My writing. So we want an adult and they only like chocolate or strawberry. So we look at where adult and chocolate intersect. Start there. Adult and chocolate. So again, we're only looking in the adult section here. Adult and chocolate is going to be 55. We need to add adult and strawberry. So only the row that has adult, and we're looking at strawberry, and we're going to find that is going to be 10. So we're going to add those together to get 65. And now we have our two numbers, 65 in the numerator, 119 in the denominator, and this will be simplified. Now, I went a little fast here, but hopefully we're getting the concept. If you're a little confused, you can go ahead and ask your teacher for questions, clarifications, or search YouTube for other videos dealing with conditional property and two-way tables.